Air pollution is characterized by a high concentration of particulate matter that can cause harm to humans and the surrounding environment. Particulate matter is classified on three categories based on its physical state properties: solid particles that consist of rocks, minerals, metals, and organic matter, including bacteria; gases, aerosols that are presented by liquid droplets of different chemistries. The U.S. EPA recognizes two categories of particulate matter, based partly on the size of the particles and partly on their origin. Particulate matter, PM 2.5. Five particles with diameters of 2.5 micrometers or smaller. They can be found in smoke and haze originated from forest fires, power plants, and other industries, and automobile engines that emit gases into the air. Particulate matter 2.5 to particulate matter 10. Inhalable coarse particles with diameters in range of 2.5 to 10 micrometers. These particles are composed of dust occurring in the vicinity of roadways, construction areas, and dusty industries. The schematic picture demonstrates the main concept of the particulate matter, interactions, and their diversity within them are: the greenhouse effect, particulate matter from land, ultraviolet radiation, acidic rain, increases of ground level of ozone concentration, and nitrogen oxides concentration. Let's consider them. What is the greenhouse effect? The greenhouse effect may be imagined in this way. Think of the inside of a car in the summer. Ultraviolet radiation from the sun passes through the glass, warms up the seats, and gets trapped. Heat, infrared radiation, doesn't pass back out through the glass easily. Now you have a greenhouse effect inside of your car. The greenhouse effect is formed in the atmosphere due to elevated concentrations of gases that can absorb and emit infrared radiation. The most abundant gases that cause the greenhouse effect are water vapor, H2O, carbon dioxide, CO2, nitrous oxide, N2O, ozone, O3, and chlorofluorocarbons, CFCs. Particulate matter from agricultural lands and geological and atmospheric processes, volcanoes, earthquakes, rooks, weathering, tornadoes, windstorms. More about geological particulate matter in Module 7. Example: the rock on the right, called diatomite, consists of tiny fossilized microorganisms, diatoms, which shells are made from SiO2. Powdered diatomite, S1O2, is widely used for industrial needs as a great absorbent, abrasive materials for filtrations, for pest control, and for purifications. Inhalation of small particles of SiO2 causes silicosis, a lung disease. 3. Ultraviolet radiation from the sun. The World Health Organization classifies UV radiation from sun and from tanning beds as a human carcinogen. Many industries are accompanied by the emission of carbon dioxide, sulfur dioxide, and nitrogen oxides into the atmosphere. These gases react with the droplets of water and precipitate down to the earth as acid rain. The acidity of rain can be monitored by measurement of pH. For comparison, you should remember that pure drinking water has a pH of 7.0. A normal rainfall is slightly acidic, pH equals 5.6 to 4.5, with average number pH 5. The main reactions causing acid rain reside with formation of carbonic, nitric, and sulfuric acids. When gases such as carbon dioxide, nitrogen dioxide, and sulfur dioxide react with water vapor. Acidic rain may destroy forests, land and aquatic environments, buildings, historical monuments, and statues, especially those made from carbonate rocks, and cause metal corrosion. It can also affect human health by causing lung problems such as asthma and bronchitis. The image on the left shows effects of acid rain on forests in Jezera Mountains, Czech Republic, which is in the vicinity of the thermal power station, situated in Poland. The latter emitted toxic gases into the atmosphere. The harmful effects of acid rain deposits on marble statues do not need any additional explanation. Acid rain and aquatic life. Lakes and fish can be damaged by acid rain. Fish die if acid levels of the water are high. When the acid levels are too low, fish become sick and lose their reproduction abilities. Birds can die from eating toxic fish, and human health may also be affected if they eat such fish. Number 5. Ozone layer. Ozone exists in the stratosphere at the altitude of 20 to 30 kilometers, creating the so-called ozone layer. Ozone concentration in the ozone layer is 10 parts per million, while its concentration is only 0.3 parts per million in the Earth's atmosphere. The ozone layer absorbs 97 to 99% of the sun's ultraviolet radiation, which otherwise would potentially damage exposed life near the Earth's surface. Ozone hole. Why should we care? In 1976, studies in atmospheric field concluded that the ozone layer was being depleted by chemicals, chlorofluorocarbons, CFCs, which were released by industry to the atmosphere. In an August 1985 meeting in Prague, atmospheric scientist Dr. Pawan Partia presented the satellite-based image that revealed for the first time the real size and magnitude of the Antarctic ozone hole. CFCs destroy the ozone layer and increase greenhouse effect. Now you can see examples of ozone-depleting substances, ODS, made by industries. The ODS compounds are used for manufacturing different types of refrigerants, solvents, propellants, and foam-blowing agents. The discovery of the ozone hole ultimately led to the 1987 Montreal Protocol, a landmark international treaty designed to phase out ozone-depleting substances. By 2003, almost all countries except 11 ratified the Montreal Protocol. By 2016, all countries in the United Nations had ratified the Montreal Protocol. You see here a series of NASA satellite images providing evidence that the Antarctic hole is stabilized and started to heal after the Montreal Protocol actions. NASA continues their observations, and scientists predict that in compliance with the Montreal Protocol, the Antarctic ozone levels are expected to return to their pre-1980 conditions by 2050. Therefore, the Montreal Protocol was and is a successful international treaty helping to save our planet. About approximately 80% of the nitrogen oxide gases are emitted into the atmosphere from the following sources: fossil fuel burning gas, coal, oil, forest fires, tobacco smoke, exhaust emission from vehicles, food and fertilizers processing industries, metals refining and manufacturing industries. Long-term exposure increases the risk of respiratory conditions and increases the response to allergens. Nitrogen oxides also contribute to the formation of fine particles, particulate matter, and ground-level ozone, both of which are associated with adverse health effects. Scandal with Volkswagen cars. The Telegraph, September 2015. The cars in question could emit as much as 40 times the legal standard of nitrogen oxide, the EPA said. Volkswagen faced $18 billion of fines over a secret device that intentionally cut emissions, but only when the cars were being tested. Domestic dust consists of a mixture of solid particles, 0.1 to 0.6 micron size, of minerals, rocks, manufactured products, human and pet hairs, fragments of skins mixed with bacteria, and special dust mites. Dust of such small size, less than 1 micron, is easily inhaled by humans. It passes through the respiratory tract and deep into lungs, where it's stagnated for the rest of life, causing asthma and more severe diseases. Though the mechanism of the asthma is not completely recognized, its connection to home dust is established. How to deal with dust in your house. Please choose the right ways. This table is given for your convenience to learn what to do if you live in an area affected by dust. Now prepare for a quiz.